name's Paul Strykowski, President and co-founder of CounterFlow Technologies. We, at our company, is excited to pronounce today a new breakthrough technology, a platform technology in spraying. Now, to be honest, most of you have never thought much about spraying, but it is everywhere. It's in agriculture, it's in coatings. Spray coatings are very common, wear coatings, thermal coatings, it's in combustion processing, food processing, and many, many powdered foods, powdered dyes, and powdered pharmaceuticals. Now, what we bring is really, this technology, generally speaking, spraying's been around for almost 100 years, and we are able to spray very viscous liquids, virtually 10 times more viscous than anyone else in the industry. That means 10 times thicker. There are immediate advantages to this technology. At the outset, we can save at least 50% of the energy. In the US alone, an annual amount, we're talking about hundreds of millions of dollars. Correspondingly, we reduce the CO2 footprint depending on the energy source. It's also able, in spray drying technology, to reduce the water content and the energy required to evaporate that water. And also because the capital investment is so high, we can increase productivity in the spray drying market with almost no capital investment with our technology. And that is because we use a very easily retrofittable technology, which really reduces the barrier to get into the market. Our technology, traditional spraying, has been done with basically co-flowing fluids. A viscous liquid needs to be broken up into droplets for some process. That is usually done traditionally by a gas flowing stream in the co-flowing direction. That gas is impinged at very high velocity onto the liquid, breaking it into filaments and then droplets. Our technology is a simple but radical change. Here, we take the gas and the liquid, initially co-flow, but we turn the gas 180 degrees to create a counter-flowing, very violent, turbulent mixing zone, which creates a homogeneous, uniform, bubbly flow, which in some sense pre-atomizes it, so the flow exits already properly atomized. Furthermore, you'll notice our nozzle has a larger exit diameter. This reduces wear, which means replacement costs are less frequent, and it reduces clogging. This is an example on the right of an easily retrofittable system. The hardware for these systems can be quite large. However, the components that spray are introduced into the existing hardware. Current technology is on the left. Our technology drops into that same housing, reduces the energy to spray by 50%, and simultaneously gives us a better quality spray. Where have we come? What do we need? We've demonstrated that's retrofittable in multiple different markets. We have 2 patents learned last week that our primary independent claim, the broadest claim, as well as the 12 dependent claims, were allowable by the US Patent Office. This is very exciting news for us. We've done extensive market research. We've talked to more than 30 companies. We have 6 current mutual NDAs. This has allowed us to go into facilities and test our nozzles at scale. These are not small scale, but very, very large scale that industry needs. We've also been I've been very blessed to have an outstanding team. Many of us have been together 15 years. We brought on another player for us involved in commercialization experience, has been on for about 5 years. And we are doing research here at the University of Minnesota, Twin Cities, and the University of Minnesota Duluth to advance the fundamental understanding. What we need, we're looking for a team member with relevant business experience, particularly with interest in this and a knowledge in this sector. And we're looking for a lead investor, a thoughtful individual who can also work with us and give us some guidance and direction as we move forward. Thank you very much.